So technically in the last video, before I jump into it, we have seen too much success to have become obsessed with failure. Ooh, I love that. That works. Manipulation 3. So filtering. So we did filtering and selects in the last video. In this video, we're going to talk about filtering, but with the OR. So in the last situation, and I'm going to actually go back to those notes because I'm recording back to back. This mod 1, if you look at it, it says that miles per gallon has to be equal to 20 and AM has to be equal to 1. So all the wrong data frame. This one. All the AMs are equal to 1, if you see that, and the miles per gallons are greater than 20. Okay. And so the reason why I bring that up and the reason why that's important here is that, let's say, for example, it's an OR. Okay, it's an OR. When it's OR, what that means is that either one can be true. As long as one of them is true, that's going to be saved. This is probably not a great data frame name anymore, now that we're doing it in the same fashion, and it's OR. And I'm just going to just put an OR in between, just so it looks, so that it works, it makes sense. Okay. I could have put an and before, but it's fine. So I viewed wrong one. This is the one. And so here, as you can see, AM is not, there's some zeros here. But the times that are zeros, those miles per gallon are greater than 20. Right? Same thing here. Alright, and some of them have miles per gallon that are less than 20. These three is because AM is equal to 1. And so as you can see, let's say, for example, you're looking at analyzing, I don't know, Kendrick Lamar. It's the first person that came to my mind. And you want either, Good Kid, Mad City. Let's say you all know the albums, or you want, I guess, Damn, you want those two albums. You can actually create the filter so that album name is equal to this or is equal to that. And you can see how that could be, needed when it comes to, like, if you want to compare those two albums' energy level, for example. Okay, so that is that. So you can see where a filter and filtering with the or maybe and can be relatively useful. Okay, so with that being said, let's continue. So this is the and we just did the or, okay? And the question is, which one do you think is going to give you more rows? Or do you think it's going to have the same amount of rows? Okay? Or it's hard to tell, or it's like you can't tell. If you think about it a little deeper, it should be the or, because the and requires both to be true, whereas the or requires just at least one. So the or operator is going to give you more rows, it's going to capture more rows because it's considering both. Okay, it's considering both. Conditions being true. It doesn't have to have both. It doesn't have to have both of being true. Alright, so with that being the case, we can start doing some nifty things. Okay. So we can have multiple pipes. So what this is going to do is going to look at the empty cars, right? And then filter only on the transmissions. I think these are manual cars. We'll look at that in a moment. And then summarize it. Okay, so as you can see, we're reading it rather than it being a function, then a function, then a function. Okay? So let's go ahead and just run this code. Okay, and so this is telling me I'm going to take the empty cars data frame, look at only AM is equal to 1, check it if it's equal to 1, and then summarizing it. And so here, this is giving me all the cars at which transmission is equal to 1. If you go back to help, yeah, transmission is manual. And if you double check, if you look at AM, all the values for AM is equal to 1, which is nice. It tells you that it worked. Another big thing to notice is that it gives you the 5-number summary, the minimum, the maximum, the first and third quartile, and the median, but it also gives you the average. So be aware of that. That's definitely important information to be given. All right, let's continue. What is the average horsepower for cars that have 4 cylinders and over 25 miles per gallon? Wow. Why don't you all try that? Go ahead and try that. So what's important to note here is that it says and. It says and. And because of time, I'm just going to show you the answer. Hopefully you did it, and then I'm not going to think through it. For now, and just I'm going to copy this, go back to R, create a new R chunk, and notice that that and shows up. It's not or, so both conditions need to be true in order for this to run. So miles per gallon has to be greater than 25, and then the cylinder has to be equal to 4. So we do this, and it says, look at horsepower, I believe. It's 75.5. And the answer is 75.5. Alright? So good work. Good work. So mutate. Now this is where we have to take a step back and just appreciate what's going on. So select allows us to grab certain variables from a data frame or to remove variables. Filter allows us to change, or at least to filter on the rows. So select as columns, filter is on the rows. So we're able to filter on certain conditions. Whereas mutate allows us to create new variables. So come to find out, we can, there's in, I believe in European countries, there's kilometers per liter. We can convert miles per gallon by doing this conversion, and then this will be your KPL. So this is mutate. So the very first argument is always the data frame. You plug it into the mutate, and you're able to create a new variable. Okay. Same thing here. Okay. So now here I'm doubling the horsepower. Okay, and then I'm converting miles per gallon here. I'm converting miles per gallon into KPL. So why don't you all do this? Create a variable called weight by power that divides weight of a car divided by the gross horsepower within the mod 2 car's data frame. Or you can create one, you create the name. You can use the MC car's data frame, I'm okay with that. And then you can just save it as mod 3. I'm okay. Okay. And I want you to review the data frame to make sure that it actually works. Alright, so here is the actual code. So for some reason I'm getting formatting. Okay, so do this, Control-Alt-I, paste this, okay. And we get the mutate function, weight by power, weight divided by horsepower. Oh, it didn't work. Okay, that makes sense. I made a mistake. Call this MT cars, okay. And then go to environment and mod 3 MT cars. We get the weight divided by power. Okay. So that worked. Great. So when it comes to mutate, you can also do some really nifty things. Let me show you. This little thing here is row names to column. So what does that mean? If you go back to the data frame for MT cars, these are row names. Okay, these are row names. What we can do is turn these row names into an actual column. At times, there are going to be some data frames that sometimes do this. Most likely going to be built-in data frames, but this is still a skill set that's worth having. So what we do is we run this function, or at least we run this call. Okay, these lines of code. Sorry, brain fart. I'm going to use MC cars, and then I'm going to name this mod 4. Don't know where these indexes are coming from. Run this mod 4, and then when we go to mod 4, we'll notice that we now have a data frame called, or at least a variable called car name that actually has the car names. The reason why I'm bringing this up is because once we have that, we're going to start doing some mutations or filtering based off of the actual variable car name. What do I mean by that is that we can actually create a new variable, right, and remove the word. I mean, this is not necessarily, this worthy thing to do, but this is still something that's worth noting you all. So here I'm going to use this as mod 4. This is mod 4. And watch what my logic. Since I'm using that as mod 4, I use this as 4. I'm going to name this 5. And what this string remove function allows me to do within the mutate function, allows me to remove every single car name that has the word Merc for Mercedes. So here you can see Merc. All these will go away once I go to mod 5 data frame. So mod 5 data frame will no longer have those Mercs. Those are gone. So string remove will allow us to do that. Okay, fun. There's some other string functionalities. Okay, string detect. This allows us to return. You know what? I'm just going to copy and paste this part of it. And string detect, the text of a certain string is actually present within that row corresponding to that variable. What I mean by that is I'm just going to put the pipe right here, and do 2 mutates back to back, and say is Toyota. And so it's going to detect if the actual string for that particular row corresponds or has a Toyota in it. So I want to run this. Okay, is Toyota. If I sort this again, I only have two Toyotas. Okay. All right. So with that being the case, I want you all to try this on your own. Okay, try this on your own. Make sure this ISLR package is installed. This is the way you install it. You run library ISLR, and then you review college name. And so apply the changes to the data set and name it college_1. Should say _df. Create a new variable named state, where if it's true, actually, with these two, these are my challenge questions. Okay, these are my challenge. I'll go over this in class. This is my challenge question because these are not necessarily straightforward. Okay, so I want you all to try this one. Okay, all right. Well, thank you all, and I will. But wait, there's an extension. Let's do the extension. I'm getting too ahead of myself. This is fun. All right, so here, if you go to this website, this URL for Indiana, the counties, right? We want to gain access to this data frame. Okay, we gain access to this, and so if you actually copy and paste this wouldn't work because it didn't load, or maybe it should. We'll find out. It's not going to work because I didn't load the HTML package. Let me do that here. All the way at the top. I want to do this extension because it's helpful. Because now you can see something of what I mentioned earlier, and we can make this make sense now. All right. All right. So notice here, population is treated as a character. Okay. So what we can do is, in our nodes, we can actually take Indiana counties data frame, we can pipe it, right? And what am I going to do? Am I going to select? Am I going to filter? Or am I going to mutate population to make it into a number? What do you all think? Take a moment and think about it. Ideally, you would have said mutate. Okay, you're going to mutate, and you can take population, and I'm going to say, I'm going to first remove all the commas. Okay, so string remove. So technically, that's a third. So we did detect. Oh, we did do remove. So we know remove, but then now we're going to extend it. And it's called remove all, because some numbers may have double commas. So I'm going to take population, and I'm going to remove the commas, all the commas that are in the numbers. And just for funsies, I'm going to call this Indiana counties data frame. Use a pipe here. I'm going to say mod 1. Okay. And I'm going to notice that if I go to structure, of mod 1, this is still, the commas are gone, which is great in comparison, but it's not a number, it's a character. So now what I'm going to do is within that same mutate, I can do this, by the way. Population is going to be equal to, there's a function called as.numeric. So I'm going to turn it into a numeric variable by typing population. Okay. So when I run this, as.numeric. Oh, because no equal here, sorry. And then, now that I run structure, look, it turns into a number. Okay? Let's say I ignored, remember that I can comment this out. So let's say I didn't remove those commas. Let's see what happens. Okay? It says we're coercing the number, and it's not gonna work. It's gonna give you all NAs if you look at it. So that's not good. So that's why we need to first remove those commas and then turn it into a number. And then it should work. I think the extension was worth it. All right. Thank you all and have a great day.